I'm going to start by drawing out the graph of an exponential function. So here I have my axes, and then the graph is going to be this blue line here. This is just a rough sketch of the graph of a quadratic function. And this brings up one of the essential questions, which I'll write as EQ. One of the essential questions when we're talking about quadratic functions and just functions in general. And that question is, for which values of x will y equal 0? For which values of x will y equal 0? And another way that you can think about this question is, for which values of x will the graph be intersecting the x-axis, or what will our x-intercepts be? This is important for things like profit and loss in a business, for example. This might model the profits of a business relative to sales or something like that, and we want to know at which points we're making money and which points we're not making money. And if I were just going to draw out those points on the graph, then it'd be these intersection points right here. Now I'm going to draw out write out the equation for this graph. Again, this is just a rough sketch of this graph, but the equation is y is equal to x subtract 3 times x subtract 4. Now this is the equation of a quadratic function. It looks different than what we've seen before. We've seen standard form before. This is actually called factored form. Let me write out factored form. And you might be able to guess that it's called factored form because we've broken the equation up into its two factors. So this is one factor and this is another factor. These are factors, two factors for this quadratic equation. Now, if we wanted to find out where this function crossed the x-axis, or where y was equal to 0, then one way that we could do that is that we could set the equation equal to 0. So we could say, if we want to know when y is equal to 0, remember that's what we're looking for up here, then we can just replace y with 0, like this. And so now we have y is equal to x subtract 3 times x subtract 4. So now there's something called the zero product property. I'll write that up here, the zero product property. And the zero product property states that if you multiply two things together and their product, or the result, is 0, then one of the things that you're multiplying together must be 0. So to write this out, we'll say if a times b equals 0, then a is equal to 0, or b is equal to 0. Or both of them are equal to 0. Now the way that applies, the way that the zero product property applies to our equation here, is that in order for the left-hand side to be 0, then either this factor must be 0, must be equal to 0, or this factor must be equal to 0. So let me write that out. Either x subtract 3 is equal to 0, so that would make it true, or x subtract 4, oops, there's that 4 again, x subtract 4 is equal to 0. Now the next question is, what value of x makes these two equations true? Well, you might be able to see for this equation that it's just that x must be equal to 3 in order for this to be true, but we can also use a little bit of algebra here. We can add 3 to both sides, and then that gives us x is equal to 3. So if x is equal to 3, then y must be equal to 0. And that would mean that this point right here must be, let's see if I can write this small enough, that this point must be at 3, 0. And then similarly over here, we can use a little bit of algebra, add 4 to both sides. I'll try that again. We can add 4 to both sides. Jeez, these 4s killing me. Okay, we can add 4 to both sides, and that gives us x is equal to 4. So that would mean that this point right here would be at 4, 4s, man, 4 comma 0. There we go. 4 comma 0. So either x is equal to 3, that would make this true, or x is equal to 4. That would make this equation true also, and that's because of the zero product property. Now I want to rewind just a little bit and show the relationship between this form, this factored form, how that relates to our standard form that we saw earlier. Now if I rewrite this equation as y is equal to x subtract 3 times x subtract 4, I can manipulate this to put it into standard form, and the way that I do that is just by distributing the parentheses over one another. And so there's a few ways that we can keep track of this so that we end up with so that we end up with the equation in the correct standard form. There's two ways, so I'm going to walk you through both of them, and you can choose which one you think makes more sense for you. They're equivalent. So one is called each by each. Each by each, and the basic idea with each by each is that you take the terms inside each factor, and you make sure that you multiply both terms in this factor by both terms in that factor. So let me write out what that actually looks like. So in our first factor here, we have an x and we have a -3. And in our second factor, we have an x and we have a -4. And so I just need to make sure that I multiply x by both x and -4, and then I multiply -3 by both x and -4. And so in terms of arrows, I multiply my x by the other x and the -4, and then I multiply the -3 by the x and the -3 by the -4. And so I'll go ahead and do that. X times x is going to be x squared. And then x times -4 is going to be -4x. Maybe I'll do this in columns first. I don't know why all my 4s look like 9s. I have -4x, that's just x times -4. And now I'm going to look at my -3 down here. -3 times x is going to be -3x. And then -3 times -4 is going to be +12. And so I'm just going to assemble all of these terms into one expression. So that's going to be y is equal to x squared subtract 3x subtract 4x plus 12. And then I can combine like terms. So this becomes y is equal to x squared. I combine these two. Subtract 7x, because -3x subtract 4x is -7x. And then plus 12. And so I've taken this equation in factored form and converted it into standard form. Notice it's in standard form because we're going down in degree for each variable. We have this is to the second power, to the first power, and then no variable there. Now the other way that we can think about converting from factored form into standard form is with what's called FOIL. And this is how I learned when I was in school. I like each by each better, but I'll teach you FOIL also. So with FOIL, we multiply the first terms, and then we multiply the outer terms, and then we multiply the inner terms, and then we multiply the last terms. So if I rewrote the equation in factored form here as y is equal to x subtract 3 times x subtract 4, and I multiplied my first terms first, so the first terms in each factor. Remember that the factor is the stuff inside the parentheses, and then the terms are the individual parts inside of the parentheses. So if I multiplied the first terms, that would be the x and the x, which would multiply to x squared. And then my outer terms would be the x and the -4, like that. and then my inner terms are going to be my -3 and my negative x, or sorry, my -3 and my x, and then my last terms are going to be my -3 and my -4. So you'd multiply those out, and then you would just reassemble following the same steps here. You'd take the individual parts and put them together into one expression and then combine like terms, and you would get the same answer. The thing that's valuable about doing each by each is that you can use each by each even when you have even when you have factors with 3 terms inside. And so if you had something like a plus b plus c and d plus e plus f, the first, outer, inner, last doesn't work for something like this, but each by each would. You can map each by each onto something like this quite easily. So anyway, we have each by each and we have FOIL. You choose whichever one works best for you. Now let's say that we have an equation in standard form like this here. I'll put a box around it. We have an equation in standard form, and we want to break it out into factors. We want to convert it from standard form here in red into factored form like this. So let's see how to do that. So I'm going to rewrite the equation in standard form. I'm going to rewrite it with some special coloring, and you'll see why in just a moment. So it's y is equal to 1x squared. Now down here we just had x squared, but remember there's multiplying by 1 gives us the same result, and so there's an implied 1 in here. So and it'll be clear why we have that in a little bit. And so y is equal to 1x squared, and then subtract 7. Subtract 7x plus 12. Plus 12. Now I want to keep track of these coefficients. The coefficients are these numbers here. I want to keep track of them, and I'm going to give them letter names. And so the first is going to be A. The 1 is going to be A, and the B is going to be -7. And the C is going to be 12. So the 1 is my A, the -7 is my B, and the C is my 12. Now the reason that I've written out the coefficients in different colors and given them letter names is because when we have an equation in standard form that looks like this, then in order to factor it, we need to find two numbers. We need to find two numbers that multiply to C. Two numbers that multiply to C, or multiply together such that C is their product. I'll use the right color here. Multiply to C and add together. That looks like a D. Let's see. And add together to B, which I'll put in yellow. So we want to find two numbers that multiply to C and add to B, and then those two numbers are going to be our terms inside of each factor when it's in factored form. So if I'm looking for numbers that multiply together to C, I'm going to write those out. So I'll just use a little arrow here. Now what are the numbers? Maybe I should do this in light blue. What are the numbers that multiply together to make 12? I should say that the integers that multiply together to make 12. Well, we know that 1 times 12 is 12, and we know that 2 times 6 is 12, and we know that 3 times 4 is 12. And the negatives are also going to multiply together to 12. So -1 times -12, and then -2 times -6. I should put multiplication signs here. And -3 times -4. Now these are the numbers that multiply together to make 12, and so we want to find which of these two numbers, when we add them together, makes b, or negative 7. So 1 plus 12 doesn't make negative 7, so that's out. 2 plus 6 makes 8, so that doesn't work. 3 plus 4 makes 7, that doesn't work. Negative 1 plus negative 12 makes negative 13, that doesn't work. Negative 2 plus negative 6 makes negative 8, so that doesn't work. But then we have negative 3 plus negative 4, that's going to be equal to negative 7, and that's what we're looking for because that's what b is equal to. And so these are the two numbers that multiply to c, or multiply together to make 12, and add together to make b, which is negative 7. And so I'm going to use those two numbers to rewrite this equation in factored form. So that's going to be y is equal to x subtract 3, and then x subtract 4, because those are the two numbers that multiply to make 12 and add together to make negative 7. So now we have the equation in factored form, and this is what we started with over on the left-hand side here. So we've gone from factored form, and we distributed using each by each and FOIL to get to our standard form, and then we factor that standard form back out into our factored form here. And so if I hadn't started from here, then I would multiply this back out again into standard form and just make sure that I had factored this correctly, just to check my work. Let's do another one of these before we finish. We can just see it with a different equation. So let's say we have y is equal to x squared subtract 2x and then subtract 8. So now, looking back at this rule up here, or these directions, so to speak, we need to find two numbers that multiply to c, or multiply to negative 8, and then we also need to find numbers that add together to b. So they need to be the same numbers that multiply to make c, or negative 8, and then add together to make b, or negative 2. You could make out a list of numbers here. Let's see, let me do this in a consistent color. You could make out a list of numbers. I just happen to know off the top of my head that negative 4 times 2 makes negative 8. So if I have negative 4 times 2, that's going to make negative 8. And then negative 4 plus 2, so negative 4, those 4's again, negative 4 plus 2 is going to make negative 2. And so these must be my two numbers. And so this in factored form, this equation in factored form is going to be, let me write it in the right color here. Y is equal to x subtract 4 times x plus 2.